Hey everybody, it's Brad here, the creator of Expanse, the volumetric cloud skies and atmospheres plugin for Unity's high definition render pipeline. And I'm back with another tutorial. I know it's been a little while, things have been kind of busy with the release, but I've been wanting to make this tutorial for a while. Today we're going to talk about how to customize Expanse to give you more control over your cloudscapes. This could mean everything from, placing clouds in different spots to authoring your own noises, and we're going to see a bunch of different strategies for how to do that. Before we dive into the tutorial, though, I just want to say that I am super grateful for all the people who have come out in support of Expanse and have tried the plugin and are using it to do all sorts of cool stuff. I don't know if anybody follows CodeMonkey, but they recently named Expanse their #1 Unity plugin for June 2021, which is super cool. And we've got our great Discord community going, some positive reviews on the asset store. People are really doing cool stuff with Expanse, and that makes me super happy. Thank you, everybody, for supporting Expanse. It means a lot, and there's more exciting stuff to come, and I can't wait to see what you guys all do with this tool. All right, with that covered, we can start talking about clouds. The motivation for this tutorial is that Expanse is pretty good at creating cloudscapes that look like this, or maybe like this. But it's not so good at creating clouds that look like this, or maybe like this. And you might be able to tell the difference between these two sets of images. In the first two images, the clouds are kind of scattered around the sky in a way that appears almost random. And in the second two images, the clouds are in very semantically meaningful spots. So in this image, we have sort of a storm front where one half of the sky is covered in dense altostratus clouds, and the other side of the sky is very clear. And here we have a cloud that's placed directly, it's formed directly on top of Mount Fuji. And as artists, sometimes trying to mimic the real world and sometimes trying to create contrived scenarios for the purpose of narrative and storytelling, sometimes we just want to put clouds in a spot deliberately. And Expanse's procedural authoring sort of noise-based tools, they're not always the best for this kind of thing. So if you're me and you're sitting in the middle of quarantine 5 or 6 months ago and you're trying to figure out how to do this, what strategy do you think you would come up with? Certainly one that you could think of is that maybe you could paint clouds where you want in the sky. So you would sort of open up edit mode, you would take a look at a spot in the sky, you'd select a brush tool, and then you would paint and clouds would appear in that spot. This would be pretty cool, but it's actually pretty challenging to implement. And the bigger thing is that it can't easily be adjusted programmatically. So if there was just a paint tool for painting clouds, then it would be harder to randomly scatter clouds where you want to, or even to animate those clouds as well. You could imagine also having something like individual cloud volumes where you make clouds individually and then you place each smaller cloud, you scatter them around, and that creates your cloudscape. This is just too expensive because you have to render each cloud volume individually, and it's way more efficient if you can render them all as part of one big cloud volume. And in addition to that, as an artist, you'd have to keep track of all these small cloud volumes, and that's kind of annoying, and you have to hand place them, and you need scatter tools, and this doesn't always really create a convincing result. So the solution that we're going to roll with, well, that Expanse already does roll with and does use, is something called a coverage map. And if it's not clear by this image, a coverage map is a 2D texture. And the black areas of the texture are where the clouds are, and the white areas are where there are no clouds. You can easily author these in Photoshop or other image editors. You can generate them programmatically, and surprise, you can actually paint them in an editor if you have a plugin like Polybrush that lets you paint a texture in real time in Unity. And so the paint solution, it's actually still there. You can actually still draw stuff, but you just need to use one of these third-party plugins like Polybrush. And so they're actually a pretty good general solution to the idea of hand placing clouds, because you can easily have procedural versions of coverage maps that place clouds randomly, which is what Expanse does by default. Or you can hand author a coverage map in a number of different ways, and you can use that instead. So we're going to talk about a couple different ways to do that, to hand author coverage maps. The first thing we're going to do is we're just going to use an existing image as a coverage map. The second thing is we're going to learn how to create an image in Photoshop that looks like a good coverage map, because there's some things that look good and some things that look bad, and so we'll talk about that. And then we're going to learn how to create a coverage map with nodes, with the shader editor. I wish I could have used Unity's shader graph for this, but shader graph and HDRP don't mix that well when you're trying to render the material out to a custom render texture. And I hope that they fix this soon, but instead I'm going to use Amplify shader editor, which is a great cool asset. And then the fourth thing we're going to do is we're actually going to use code to procedurally generate a coverage map. And I promise that it's not going to be too involved. It's not going to be too many lines. And if it's interesting to you, then you can take a look. And if it's not, then you can skip it. Okay, so I've got Unity open up here, and I have a basic sky loaded in. If you don't know how to get a sky loaded into Expanse or to initialize something like this, I recommend you watch the tutorial video on how to do that, and I'll link that here. It's the Getting Started video. And you can see we have no clouds. So the first thing we're going to do is we're going to create a cloud volume. And the way we're going to do that is we're going to go over to the game object hierarchy. We're going to right click and we're going to click Create Empty. I'm going to rename this to Clouds. And then I'm going to add a procedural cloud volume block. And then what I'm going to do after this is I'm going to select a preset. And that preset, I think I'm going to go with Operation B, and I'm going to make sure to select the optimized version of the preset, because that is going to make it so that my GPU doesn't melt. So I'm going to click that, and then I'm going to uncheck and recheck it, and there we go. Now we have clouds. Okay, so I've got clouds in the scene now. You can see that they're scattered around kind of randomly. And the first thing I'm going to do is I'm going to, like I said, show you how to use just a regular image to determine where the clouds are. So let me sort of come back up here and look at the clouds from high up. And then I'm going to pop over to the Noise Editor tab. And I'm going to go to the Layer Select and click Coverage. And this is where we specify our coverage map. You can see by default, it's the procedural checkbox is selected. And what this does is it means that we will use whatever noise parameters here to generate the coverage map. So you can see if I select a different type of noise, then it'll look different. You know, there's a bunch of different ones, and you can play around with this, but that's not what we're going to talk about today. We're talking about how to create a custom one. So we are going to uncheck procedural. And you can see that now this just defaults to basically the whole sky is covered in clouds. And there's a spot here for a texture. So I'm going to go online. I'm going to look up smiley face. Some of these are kind of creepy. Look at that thing. That's like a freaking PCP smiley face. All right. Let's grab this one. This looks good. I'll save this. Just smile. And I'm going to come over here and I'll create a new folder here. And I'm going to call it Custom Coverage Maps. Open that and drag in smile.jpg. Okay. And now I'm going to pop back over to the clouds. And I'm just going to drag this over to the texture field. And there we go. We got a big smile. And, you know, you can imagine, I don't know, tiling this. And you can up the tile factor. And, yeah, that'll put a bunch of smiley faces down. And you can have a ton of them if you want. That looks pretty creepy. So, yeah, you know, you could imagine using something better than a smiley face, right? If I look up something like Perlin noise, and I don't know, download this picture, Perlin, and drag that in, then use that. That works pretty well as a coverage texture too. But the reason I use the smiley face thing is that just to make the point that you can really create any kind of shape that you want and use it here, and it'll work as a coverage texture. So yeah. So that's how you do this. That's pretty much the simplest way to customize your coverage map is to just drag an image in here. So you can imagine that the possibilities here are actually kind of limitless because you can put any image you want in this texture situation, this little texture field, right? And it'll use that as the coverage map. That image can be something you found from Google, like a smiley face. It can be something that you generate on the fly in Unity, or it can be something that you draw and then take a picture of and then put it in there and it'll work. So the next logical step here is to say, well, most of the time we're going to want to sort of hand author these coverage maps and create something that's not just a smiley face, but maybe something that looks a little more realistic. And so we can use an image editor to do that. So I'm going to open up Photoshop, which is the one that I use, and I'll make it 4K, 4x4,000 pixels. You can always downscale it in Unity to make it more performant. Okay, so I got my empty Photoshop canvas here, and the first thing I am going to do is go to Layer, hit New, click Layer. I'm going to call it, I don't know, let's make a storm front. I'm going to call it Storm Front. Great. And now I am just going to grab the brush tool. I'm going to pick the regular sort of soft brush. I'm going to set the color to black, increase the size, and I'm just going to paint a storm front. There you go, storm front. Maybe I'll put sort of a smaller one, I don't know, over here. Maybe there's like a little cloud hanging out in that section, and one over here, and maybe one here, and then a couple of small guys right here. Cool. All right, so that looks good. Now I'm just going to go to File, Export, Quick Export as PNG. I'm going to navigate to the folder in Unity that has my custom coverage maps, and I'm going to save this as Stormfront 1. Great, and now I open up Unity, and you can see I have my little my little image here, Stormfront 1. I'm going to go over to the clouds, and I'm going to set the tile factor to 1 and drag in the Stormfront. And there you go. We got something here. Of course, there might be other problems, right? One thing I can already see is that this looks kind of shifted, and I think that's because we got to go into the Movement tab and set the coverage offset to 0. And then the other thing is that we can't see the edges of the cloud volume because we have an attenuation thing set up. So I'm going to go to the Modeling tab, and I'm just going to set the attenuation distance to something big like 100,000. And now we can see the whole cloud volume. And you can see my little specks of cloud here, right? So this looks okay. I mean, we can up the coverage intensity and change that and get some stuff. But it looks very uniform and very boring. And it doesn't really look that realistic. I mean, the clouds are where we want them to be, but if we go down to back down to where the camera is, it looks a little strange, honestly. It's like there's all these clouds over here, and then they just thin out completely linearly over here, and then we have these big blobs off in the distance. So it's not really the best looking coverage map. So we can do a better job, I think. So let's open up Photoshop again. So I'm going to disable this layer, and I'm going to create a new layer. I'm going to call this Stormfront 2. And I am going to select a different brush. So instead of just using the soft round brush, I'm going to use a more interesting kind of textured brush to do this. And I'll link this brush collection. It's a free brush collection for Photoshop, and you might be able to use it in other softwares. I don't know, but you just Google Photoshop brushes. You'll find tons of them, and you can play around and experiment, see what you like. I'm going to use this one. This looks kind of cool. And I am just going to start kind of clicking around and placing little dots, and just kind of building up a different look here. Okay, you can already tell that this is going to take a long time, right? I'm not going to actually do this. I'm going to come over here to the brush options, and I'm going to go to scattering, and I am going to up the scatter count and up the scatter percent, and I'm going to click both axes. And now you can see it's scattering it around a little more. In fact, I'm going to up the count even more. That looks pretty nice. And now I'm going to come over here to shape dynamics and go to roundness jitter and up that, angle jitter up that, and I'm going to go to size jitter and up that as well. And now we're going to get a really varied looking sort of cloud brush. And you can see if we do that, it's going to go nuts, right? So I'm actually going to undo everything I just did, and I'm going to use this better looking brush to place all of these clouds. There you go. Just start doing this, getting them around here. I'm just going to place sort of a number of them. And I'm going to kind of angle my storm front a little. It's going to kind of look like it's going to be a little bit circular. Okay, that's all right. I'm going to pick another one now, a different brush. Maybe one that's a little bit kind of softer looking like this. And I'll do the same thing here. And maybe I'll up the size even more and kind of start filling in the gaps with some of this stuff. Okay, I'm going to pick a different brush now too. Let's try, this one looks pretty good actually. Let's give this a try. And let's up this, let's keep the size at like there. Okay, and let's go to the scattering tool. We're going to up the count, up the amount of scattering, both axes, and then we're going to get the size to change. I'm going to place some more of these around here. And this is all going to look, I'm going to kind of make it pretty uniform just because I think that storm fronts are usually pretty uniform looking. You know, they don't have a lot of variation in them, but they have enough where it's good that we're using these noise textures to do it. But they're pretty solid wall of clouds. All right. I think that looks good. Now I'm actually gonna bring down the scatter amount for the brush, and I'm gonna now come over here and try to sort of define the outline a little bit more and get the edge stronger. And I'm going to come and use a different brush and sort of get some variation along the edge. Great. Okay, this looks pretty good, I think, right now. The only other thing I want to do is that I don't want this to just be clouds and then no clouds over here. I want to have a couple of sort of like, you know, swathy looking things over here, just a couple of little clouds. So I'm going to go and I'm going to grab kind of a soft looking one like this. I'm just going to kind of create a little, let's make it smaller, a little line over here. And then I'm going to come in for some of these more defined shapes. And I'm going to get a couple of those in there. And you can really be, I mean, you can get kind of nuts with this, you know? Like, you don't need to be reserved and careful. Like, clouds look freaking weird, you know? Like, that's what they look strange. It's like that's what they look like, you know? So you don't need to be sort of trying to make, oh, like little perfect clouds, you know? No. Like, make it look like messy. All right, so I think that looks pretty good, at least for a first pass. You can see here is our old storm front, the one that looked kind of like crap. And here's the new one, and it's way more detailed, way more interesting looking. And so yeah, let's export this. Let's load it into Unity, and let's see what it looks like. I'll call it Storm Front 2. We're going to go to the clouds, go to Noise Editor, and drag in the texture. That looks more interesting to me. Yeah, I think that actually looks really cool. So here's the storm front over here, and then we have sort of our scattered clouds off in this direction, right? We have sort of these little guys here, and you can see we can bump down the coverage intensity to sort of have it reduced, and then we can bump it up and get it to really like fill out if we want to. And you know, you can, if you go too far, the whole sky will be covered. But right here, I think looks pretty good. And now if we go back down to the camera, that looks like a storm front to me. Still, I don't think that this looks perfect. And the reason for it is that I'm going to come over here, and this looks pretty good, but you can kind of see that there's like a couple of little tufts here that they look pretty good in this example, actually. In some of my sort of initial explorations, you would see more stuff that looks kind of like these. It's hard to see, but like these things, right? And you can tell that this is kind of like a single pixel that's being turned into a cloud, right? Because those brushes we used were so detailed that sometimes they create shapes that are way too small to actually be clouds, right? So you have this big shape here, but then you've got this really tiny kind of weird column of cloud from a single pixel. And there's a way to get rid of those, and there's a way to actually make the coverage map look even better. So I'm going to go back into Photoshop for the last time here. And the way that I'm going to do this is I'm going to duplicate this layer. I'm going to call it Stormfront 2, Stormfront 3. And I am going to blur it. And what this is going to do is it's going to smooth out the coverage map as a whole, and you're still going to get some of that cool, interesting detail, but all the tiny little pixels, like all of like the here we go. Like all of those little guys, right? They're going to get smoothed out. And I think this is going to make our coverage look more natural and get rid of some of those artifacts. So I'm going to go to Filter. Let me click the layer, Filter, Blur, Gaussian Blur, radius of 20 pixels, and I'm going to hit OK. And now let's export it one more time. Pop back over to Unity. We have it here. Go to Clouds, Noise Editor, drag it in. And there you go. And now you can see the difference is that some of those little columns of clouds that you had with the first one, like these, right? They disappear with this. And the whole thing looks just a little bit more natural. So yeah, I think that looks pretty nice. You can imagine there's all sorts of different coverage maps that you could make. You could make it look like a storm front. You could hand place clouds to be in front of the sun if the position of the sun is fixed in your game. All sorts of cool different things you can do. This is really just scratching the surface of the great cool stuff you can do with Photoshop. But we're going to call it with the Photoshop stuff for now. We're going to move on to using a different strategy. If you come up with a cool coverage map and you think it looks super sick, come by the Discord, post it in the show off channel. I'd love to see it. And you can even post it for other people to use if you want. All right, so we've seen how to use an image from online, like a regular image. We've seen how to create your own image and make it look like a good coverage map to create a storm front. Now we are going to get into the more complicated stuff. The thing we're going to try to do now is use the Amplify shader editor to procedurally generate a coverage map that we can control from within the shader, from the shader parameters. If you don't have Amplify, don't worry, you can just skip this section. You can also do this probably with other different shader graph editors. Hopefully one day you'll be able to do it with Unity's shader graph editor. There's some bugs with it right now that make it not workable. Okay, so let's give that a go. So the first thing you're gonna have to do is you're gonna have to go to the the package manager, and you're going to have to import Amplify Shader Editor. So import and then download, or download and then import. I've already done that. I'm going to pop over to Amplify. I'm going to go to the plugins directory. So Amplify Shader Editor, plugins, editor resources, templates. And where it says custom RT templates, I'm going to double click that and it'll unpack it for me. So if I do that, I've already imported it, but you would do that and import it into your project. Now I'm going to go back over to my custom coverage maps folder. I'm going to right click and I'm going to go to Amplify Shader. I'm going to go to Create, Amplify Shader, Legacy, Custom RT Update. And I'm going to call this Amplify Cloud Coverage. And it's going to take a second to create it because Amplify, I guess maybe depending, I'm not trashing them, but it can be a little slow sometimes. All right, so now it's open. So what this is going to do is this is going to basically create a shader that lets us render the result of the shader to a custom render texture. And then we're going to use that render texture, which is just an image, right? It's an image that we get to update every frame. We're going to use that as the coverage map where we dragged in the hand-authored images before. So the simplest thing that we can do is I'm just going to grab a color node here. I'm going to right-click, go to color, and then I'm just going to plug it into frag color here. I'm just going to make it black. I'm going to save that. And I'm actually going to bring this over to the right tab here. That way I can look at the clouds while I'm doing this. And now I am going to create a material that uses this shader. So I'm going to go to Material. I'm going to say Amplify Cloud Matte. I'm going to select it in the inspector. And I'm going to select the shader to be Amplify Cloud Coverage. Okay, the material is created. Now we have to go to Create and create a custom render texture. I'm going to call this Amplify Coverage Texture. And I'm going to drag the material into the material slot here for the custom render texture. And now you'll see the shader path gets set to custom RT update. And I'm going to make sure the update mode is set to real time, so it updates it as we're editing and in real time. And finally, I'm going to go to the clouds, and I'm going to click Noise Editor, go to Coverage, and where we had our texture before, I'm going to drag the new render texture. And now you can see the whole sky is covered in clouds. Yeah, because our Amplify shader just renders black, which says put clouds everywhere. So let's go back in here and let's actually do something more complicated. So we can pop back into the Amplify shader editor. And the first thing we're going to want to do is we're going to want to grab the UV coordinate for the texture. This basically just tells us where on the texture we're at, what part of the texture we're rendering. So I'm going to type UV. I'm going to click texture coordinates. And I'm going to get rid of this color node. We don't need it anymore. And now I'm going to right click and I'm going to type noise. And I'm just going to go to noise generator. And I'm going to take the UV coordinate from the texture, drag it into UV, and then drag the noise out to frag color here. And you should see I can save it. And now we got something different. And here, if I extend this out, oops, you can see that it's generating noise. And now if I just type float here and drag this float into the scale value and type something like 16, it creates noise at a higher frequency, so at a higher scale. So now if I save it again, you can see now I've got coverage being generated with this noise. And now you can see, so this is kind of cool, right? We've got this noise that's being used, and it's actually updating in real time as we change the scale and save the shader. Then it updates it, which is pretty sick, I think. So I'm going to go back to 16 here. I like that. And really, at this point, the sky's the limit. Whatever you can do in this shader graph editor, in the Amplify editor, and spit out into the frag color section will control the coverage of the clouds. So I am going to do something that I think is going to be kind of fun. I'm going to try to create a storm front that I can move. And the way I'm going to do that is I am going to take the U coordinate. I'm going to create a multiply node. I'm going to put the noise into one end of the multiply. I'm going to put the U coordinate into the other end. And that's going to basically, it's basically going to mask out it's going to mask out one side of the thing, right? Because the u-coordinate's going to be big on one side and small on the other. So you can see now it's denser over here and it's less dense over here. This isn't enough for me. I want to sort of get a very clean storm front line. So I'm actually going to add a logical operator. I'm going to type if, and I have A and B here. So A is going to be U. I'm going to go to float. B, I'm going to set to 0.5. And I am going to say A greater than B. So now I get to basically pick all of the different. It looks like I get to pick all of the different results. So I'm going to here. Let's clean this up a little. Drag the texture coordinate over here. I'm going to say if A is bigger than B, I'm going to spit out 1. And also if it equals B, I don't care. That's fine. And if A is less than B, I'm going to spit out 0. And this means that for A less than B, 0 means we're going to have maximum cloud coverage, right? Because black areas are where we have clouds, and 1 means we're not going to have any clouds there. And ideally what this should do is that when the UV coordinate is greater than 0.5, there will be no clouds, and when the UV coordinate is less than 0.5, there will be tons of clouds. So I can take the result of this, and I can pipe this into the multiply, and I can hit save, and there you go. It looks a little bit silly. It doesn't look quite right. Let's see. Maybe we can play with the actual coverage result here, or the coverage intensity. If I bring that down. Actually, yeah, I think what we want to do is just make this not totally 0, but instead something like 0.25, so kind of a gray color. There you go. Yeah. And then we can actually make this greater than 1, and that'll really make it bump down the coverage intensity we get left. So yeah, there you go. And now we can sort of move this parameter, and it'll move the storm front wherever we want. All right, so yeah, we've got this basic looking storm front, and this looks okay. It looks kind of like shit, honestly. It's like very flat, pretty boring. And it's not tweakable because this is a constant. So let's improve it a little bit. So what I'm going to do is I'm going to rename float 1. I'm going to call this front position. And I'm going to change it from being a constant, which I think it should have been, a constant. I'm going to click property instead. And now, if I save that and I go to the material, you can now see that front position is now something that I can edit. So I can sort of drag in the front as I want. And now if I go back to the shader editor, what I really want to do is that I don't want this to be so flat. This just doesn't, real world storms, like they don't have a really flat storm front like that. They're like a little more like, they're kind of jagged, right? They're not totally jagged, but they're not straight lines. So I think what I'm going to do is I'm going to create another noise texture. So I'm going to copy this noise generator. I'm going to paste it up here. I'm going to copy this as well so I can control the scale. Drag that into scale. And I'm going to make sure that I drag the UV over to it as well. And now I've got another noise texture. Maybe I'll set it to be a little bit even more granular. And now I'm going to use this noise to modulate the front position. And what I mean by that is that it's 0.5 right now. I'm going to sort of make it so that it's within maybe like 0.4 and 0.6, but it's somewhere random within that, depending on where you are along the front line. So the way I'm going to do that is I'm going to add a multiply node. And here, let's make sure that this is sort of all going to be clean. So I'm going to add a multiply node. and I'm going to multiply the noise value by 0.2, or maybe 0.1 actually. And that'll scale the noise down. It's between 0 and 1. Now it'll be between 0 and 0.1. And then I'm going to have an add node. And I'm going to add that noise value to the front position value. And now instead I'm going to pipe that into B here. And now you can see we have sort of a more scattered, more frayed storm front. And if we change this value here, which controls how intense the noise is, we can move it to, I don't know, be less. Like if we did 0.03, then we get sort of a nice little fragmented storm front. But you know, it's not it's still pretty straight, which is good, but it's not like totally straight, like that, which looks pretty bad. So I think I like 0.02. Okay, and now we can have some real fun. We can take, instead of using the front position here, we can type in time, go to time, and now we can scale it by a constant amount. I'm going to use 0.01, and we can use that instead. Oops. Use that instead of the front position. And now it's not going to do anything here, but if we enter play mode, I have no idea how fast this is going to be. This might be way too fast. Okay, actually it's too slow. So let's instead of scaling it by 0.01, let's go maybe 0.05, 5 times faster. And let's try that again. Yeah, so now you can see it's really starting to roll in. And whoa, wow, that's really fast. That's maybe a little too fast, actually, now that I'm thinking about it. But anyway, you can imagine animating different parameters here and using those to make the whole thing dynamic instead of just using these. You know, you could even animate the shader property too if you want to. You could go to the material and you can animate this front position parameter, and that'll sort of control how it rolls in as well. But yeah, there you have it. That is how to use Amplify Shader Editor to create a custom coverage map that represents a storm front. So this is pretty similar to what we did in Photoshop, except now it's all in Unity and it's fully dynamic, and we can animate it and we can do whatever we want with it to create cool weather events and then make it move around. I think that's pretty cool. I don't know, maybe you don't think it's that cool, but I think it's pretty cool. I think Amplify Shader Editor is just cool as a whole. And Unity's shader graph implementation kind of sucks. So, you know, it's good that someone has gone out and implemented a better third-party one. Okay, the time has come to code. It might sound intimidating. I will say, if you have no experience programming whatsoever, I recommend you just don't watch this part. It might be extremely frustrating. I'm going to assume a basic sort of knowledge with some C# stuff, basic programming stuff. You don't need to know anything about shaders. We're not going to do anything really complicated with them. And it's going to be a pretty quick project, but just be warned, if you've never programmed before, this is probably not a good way to start. So the strategy that we're going to use to generate this coverage map is we are going to create a compute shader that will render some kind of coverage map based on some math that we do in the compute shader. And then we're going to create a C# script to invoke that compute shader on a custom render texture. And then it's the same thing from there on out. We have the render texture. It's a picture. We can take that picture and we can drag it onto the clouds object and use it as the coverage map. So the two things I'm going to need to create, I'm going to need to create a compute shader. I'm going to go to create shader, compute shader, and I'm going to call this generate coverage. And I'm going to need to create a C# script. So I'm going to type that, and I'm going to say also call that generate coverage. Great. You can see if we go to the compute shader, here it has to reload. All right, we can double click the compute shader and open that up. It'll open it in our text editor. And this is what your basic compute shader looks like. It has a function that gets invoked that writes into a texture. That's this result thing here, RW texture 2D result. So the thing I'm going to do right off the bat is our texture is just going to be RGB, or sorry, it's just going to be one component. It's not going to be RGBA. So I'm going to change this from float 4 to just float. And down here, which is where we write into this texture, I'm just going to replace this with 0 for now. And we'll come back to this. We'll explain exactly what's going on here, right? But for now, we're going to set up the C# script so we can actually invoke this compute shader. So I'm going to go back to Unity. I'm going to double click the C# script. And now we have our start and update functions, the usual mono behavior stuff. I'm going to create 2 member variables, public render texture RT, sure, render texture, that's fine. and public compute shader. And these are 2 variables that we're going to set on this game object. And then the other thing I'm going to do is I'm going to create some variables that are private for some different things that we'll need about the compute shader. So one is going to be the name of the texture in the compute shader. You can see it's called result. So I'm going to do result. I'm going to call this result text. And the other thing we're going to need is the name of this function, CS main. And they call these kernels. But it's just a function that we can invoke from C# in the compute shader. And it's called CS main. So I'm going to call this private string kernel equals CS main. Great. We don't actually need a start function. It's fine. So I'm going to delete that. And now I am going to go back to Unity and make sure that this compiles. If hopefully there's no problems. It compiles. Great. So now I'm going to go over to here and I'm going to create, actually I'm just going to put this on the cloud game object. I'm going to add component and I'm going to type in generate coverage. That's added now, and you see I have a slot for a compute shader and a render texture. I'm going to drag in my compute shader, and I'm going to create a new custom render texture. Just a regular render texture, actually. A regular render texture. I'm going to call this generated coverage map, and I'm going to drag that into the render texture slot. Now I'm going to open up Visual Studio Code again, go back to the code. And the first thing I'm going to do is I'm going to check if the compute shader or the render texture are null, just because I don't want this to totally fail. And I'm just going to return if that's the case. So we'll just skip everything if either one is null. Now I am going to invoke this compute shader and render it out to this render texture. And the way that I do that is the first thing I have to do is I have to look up the function I want to call, and it's going to give me what's called a handle back. And that handle is just an integer that just represents the function that we can then use to invoke. So the way I'm going to do that is I'm just going to say int handle equals compute shader dot find kernel, and it's trying to find the integer that represents this function, so I'm going to pass it this function's name, which is I have here as kernel. And great. That will now give us the handle we can use to invoke this compute shaders function, the CS main function. And now it's pretty simple from here on out. I just type compute shader dot set texture with the handle, and then I use the name of the texture I want to set. It's result. It's the one we're going to write into, and I set that to our render texture. So set texture, and now I just call compute shader dot dispatch, and I specify the function I want to call, which is handle, right? Because we looked up that function. We got the handle that represents it. And the other thing that I specify here is I specify the thread groups in each dimension. The only thing you need to know about this is that, and this is, you don't even need to understand what's going on here really, but you declare the number of threads that are used right here with this num threads declarator in the compute shader. And you just need to take the render texture's width, so result text.width, and divide that by the number of threads in that in the x direction. So divide by 8, and result text.height divided by 8 again, because this is 8. And then we can just use 1 for the last dimension, because there's only, it doesn't matter. There's just one thread in that dimension, so it's no big deal. So we can say, make sure we cast both of these to an integer. What's it complaining about? Oh, whoops. This shouldn't be result text. This should be render texture. This is our texture. The result text is just the string that's the name for it. Perfect. And now, ideally, if we go back over here, we should see that we don't have any compile errors. No errors. That's great to see. And we got to come back here again and do one last thing. We got to add the execute and edit mode thing here. That way, this renders this in edit mode as well. And we see the results in edit mode. And you just do the bracket and then execute in edit mode here above the class name. Cool. And then let's do something a little more complicated here. Let's instead of 0, because this isn't going to give us a great idea of whether or not we're actually, what we're doing is working, because it's just going to render out a black texture. Let's make it 0.5, so it'll be gray. And we get this error. Yes, attempting to bind texture ID 5673 as UAV, but the texture wasn't created, blah, blah, blah. There's something else that we have to do, and it's annoying because it should be exposed in the render texture settings here, but it's not. So we have to basically say that in order to use a compute shader with this texture, we have to be able to write into it randomly. So shaders have to be able to set values on the texture. And the way that we do this is, first we have to check dynamic scaling on the render texture asset. So I click the render texture asset, I check dynamic scaling, and then down here I click render texture, I take the render texture and I set enable random write to true. Usually it doesn't let you set this after you've created the render texture, but for some reason when you enable dynamic scaling, it does let you set it. This maybe is because it's recreating it every frame. I don't know. If people have better ideas about how to do this, just tell me, but this is the workaround that I found for this. So now if we come back here, now you can see our errors are gone. Okay, actually I lied when I said that we could create a regular render texture. We actually have to create a custom render texture. And regular ones, I guess they don't update when you render to them. So let's right click, go to create, custom render texture. I'm going to call this generated coverage. And now I am going to select the color format to be R16 S norm. This just makes it one channel, which is more efficient for us. I'm going to set the resolution to 1024 by 1024. I am going to go to update mode. I'm going to say real time. And I'm going to go to where it says depth buffer. I'm going to say no depth buffer. And then I'm going to check dynamic scaling. Clear. Now I'm going to go over to the generate coverage game object, and I'm going to drag in that new render texture. You can see it says setting random write mode of already created render texture isn't supported. This is fine. We're just going to go back over to generated. We're going to uncheck dynamic scaling and then check it again. And now you can see that our texture actually is updating in the editor in real time. So that's pretty cool. All right, so now you can see that if I drag this into the texture setting here on the the coverage, you might not see anything at first, but then if you go to modeling and and you drag up the coverage intensity, it will appear at some point. Because remember, we have this set to 0.5. That's the value that we're writing out, which is about half cloud, half no cloud. So you have to up the coverage intensity to see anything. Cool. So there you go. That's how you actually write to the compute. Use the compute shader to write to the custom render texture. Can we do something more interesting with it? The answer is obviously yes. Otherwise, this wouldn't be all that useful. So let's do something like, I don't know. Maybe we could try and create like a circle or something. So the way we're going to do that is we are going to go back to, we're going to go to the compute shader, and I'm going to type float for underscore res. And this is where we're going to pass in the resolution of the output texture. And now I'm going to go back over to generate coverage.cs. I'm going to type compute shader in the update function dot set vector. And we don't need to pass in the handle this time. It will set it globally. I'm going to do underscore res, which is what we called it over in the compute shader. And I'm going to make a new vector 4. And the first two components are going to be render texture dot width, render texture dot height, and 1 and 1 for the last two. And you might be saying, you're like, Brad, why did you make a float 4? That's dumb. It's a 2D texture. You could just make this a float 2 and then pass in only the 2 you need. Unity only lets you set float 4s from script. So that's why. There you go. That's the reason. A stupid reason. Maybe it's not stupid. Maybe there's a good reason for it. But anyway, so that will now get passed into our shader. We'll have access to this. And from that, we can use the ID, which is going to be the texture coordinate from 0 up to the width and up to the height. And we can use that to compute the UV, which is the normalized coordinate. So it's going to be 0 to 1. And the way I'm going to do that is I'm going to type float2 UV is equal to id.xy plus 0.5 to move it to the middle of the pixel, and now divided by underscore res.xy, and that'll give us the UV. And if we want to let's just put this as the value. Say maybe UV dot x or something, because it can only be one component, right? All right, so here's the result for that. With the coverage up high, you can't really tell, but if you go to the modeling and turn down the coverage intensity, you can see that there's more coverage on one side than there is on the other. And that's because we used the UV coordinate for the X UV coordinate as the coverage amount. So on one side it's 0, there's lots of clouds, and on the other side it's 1, there's no clouds. Let's do something a little more fun. Let's create a circle, like I said before. So the way that we could do that is we can just compute the distance of the UV coordinate from the center of the grid. And that's pretty easy. We just say the length of the UV minus float to 0.5, 0.5. That's the center of the grid. Easy enough. There you go. We got a circle. We can bring down the coverage amount, and you can see. Okay, let's make a half circle. Let's say if uv.x is less than 0.5, then distance times equals 0. Actually, half circle, 0 is no clouds, so let's use float max, or just a big number, 100. Now we got a half circle. Great. Okay. All right. Okay. Say that we want to do something a little more complicated and a little more interesting. Let's say that we want to create some kind of streaky noise that sort of has like long stripes of clouds. That would be pretty hard to do just on our own, but we can actually use some of Expanse's noise libraries to make it easier. So if we do include assets Expanse code, assets Expanse code source common noise.hlsl, and we're actually also going to have to do this, define pi 3.141159. A little bit silly that we have to do this. I'm going to fix it, don't worry, but we're going to have to do it for a second for this. If we do that, that gives us access to some noise functions. So we can declare a Perlin noise generator, and we can create noise by calling noise generator dot generate 2D layered, and we have to pass in the UV and then some constants that tell us what we want it to look like. So for the number of cells, that's going to be the scale. I'm going to pass in, we get to pick it in each direction. I'm going to go 16 by 16. The octave scale, I'm just going to do 0.5. The amplitude, I'm going to say 2, and the number of octaves, let's do 3. These don't really matter. You can play around with them, get different results. And now I'll say that that's equal to noise, and let's see if that worked. Uh-oh, we got a problem. Okay. This returns the coordinate and the result. Okay, we want dot value dot x. Okay, there you go. Now if we up the coverage intensity, you can see we're going to start getting some noise. And if we up the scale here to 64 by 64, you can see it'll get it'll be smaller clouds, and you keep doing that, and you can get smaller patterns. We said we wanted to make something streaky, so the way we're going to do that is that we're only going to have the noise go in one dimension. So it's not going to go, there's going to be no change along like the x dimension. There's only be change along the y dimension. So the way we're going to do that is instead of passing in the real UV, we're going to pass in a new float 2 that's uv.x and 0. So it's always going to, the y coordinate, it's not going to change with the y coordinate. And that now gives us these kind of streaks. And you can see if we do that. So that looks all right. I'm actually going to, I want these edges to be a little more defined. The way I'm going to do that is I'm going to use pow to square that noise value, and this will make the edges a little bit sharper. There we go. Cool. Okay. And then maybe what I'll also do is I'll reduce the tile factor here to make the bands a little bit thicker. And I'll reduce the number of layers to 2. Actually, maybe just 1. Yeah, that's pretty uniform now. I like that. So this looks okay. I mean, it's cool that we're generating noise on the GPU, like, and using that to control the clouds. I think that's pretty cool, right? But it looks kind of bad, honestly. Like, these lines are far too straight. It doesn't look that good. So I want to make it look a little better before we're done here. And the way I'm going to do that is that I think that because they're too straight, I kind of want to make them kind of squiggly. And like, like if you look up, like, I don't know, like lines of clouds online, you kind of get stuff that looks like that. I want to see if we can kind of recreate that. And there's sort of these curvy lines. And we're already well on our way, but I think we can do a better job. And the way I'm going to do that is I am going to use the noise generator. I'm going to copy that to generate an offset value. And this offset value is going to be based on the real full UV coordinate. So it's going to vary depending on the y direction and the x direction. And it's going to be a little bit bigger of a noise so that the squiggles aren't too tight. I'm going to layer it I'm going to use this third parameter, set that to 3. And I'm going to use this to modulate the x coordinate that we pass in to generate the real noise. And the effect that this is going to have, and this is a common technique, is that it's going to warp the resulting noise by the offset noise. So if I use uv.x minus offset, it's going to basically take this noise and it's going to say squiggle the result by the offset. So let's see what that looks like. And there you go, we got squiggles now. They're far too intense, but they do look pretty cool. So what we can do is we can take the offset and we can multiply it by a small value, like 0.1. And now we get more reasonable squiggles. And we can even go a little more and get cooler squiggles. So something that's a little bit more aggressive. Yeah, I like that. Something else, though, is that I feel like when I look at the pictures of the cloud lines, you know, when you look at this kind of thing, they're actually all kind of similar to each other, right? And in our image here, they're similar to each other a little bit, but they vary from spot to spot quite a bit. So I actually want to make them a little bit more similar. And the way I'm going to do that is that I am going to take this UV coordinate, and instead of using the real UV, in the x direction, I'm going to multiply it by a smaller number. And this is basically just going to mean it's going to change less over the x direction, because it's going to be we're going to sort of reduce the amount of space we're generating the noise over, so it's going to change less. So now you can see that these are all relatively similar to each other. And I'm going to up it a little bit more, maybe like 0.3. And there you go. Now you get some kind of interesting patterns. And then maybe this is also looking a little bit too, I don't know. No, this looks good enough. So now you can see, I mean, it's a little bit tough to see it from here, but if we maybe increase the altitude of the clouds, if we bring them up to like 6,200, you can see we have these little lines, and they don't look phenomenal, you know. But that's the trick of generating of writing good procedural generation code. You could imagine taking this, you know, what ultimately like 5 or 6 line function and expanding it into something more complicated that looks a lot cooler, you know. This is sort of just as to be instructive and show you a possible way of doing this. And more importantly, to show you how to use a compute shader to generate something like this. All right, well, there you have it. 4 different ways to generate coverage maps for Expanse to place clouds where you want to place them. You can use an image that you find online. You can create an image in something like Photoshop or a different image editor. You can use a custom shader editor like Amplify to sort of graphically create a shader or a noise texture. And you can actually write your own compute shaders to do it entirely programmatically if you want to. If you have questions about any of this stuff, please feel free to stop by the Discord. I'm sure that people will come up with all sorts of cool ways to generate coverage maps and even generate other parts of the cloud noises. But until then, or until the next tutorial, I'll say thanks for watching, and I hope you have a great day.